Hi, this is Mrs. Marsh. I'm going to talk to you today about the post-lab discussion for the lab comparing units of volume. So one of the first questions is, what is the formula for your line of your graph? So we have a graph, and you have a y and x axis. On the y-axis is specifically, for this lab, the calculated volume in cubic centimeters. For the x-axis is always the independent variable. For this specific lab, it is measured in milliliters. So the generic formula for a line, and many of you will find that you have a positive slope, which means that there's a straight line that starts in the lower left-hand corner and slopes upward toward the upper right-hand corner. The formula for a line on a graph is y equals mx plus b. So for us, we're actually going to substitute in some information. Y is the calculated volume, and instead of x, it is the measured volume. That is what we had graphed on our graph. We also have an m that's in the formula. So m is the slope. So when you look at the information after you do the line of best fit, there is some data that pops up, and it will tell you what the units are. What we find out the units are cubic centimeters over milliliters. A better way of saying this is cubic centimeters for every milliliter. As an example, you may find that your slope is 0.9 cubic centimeters for every milliliter, which means you need 0.9 cubic centimeters for every 1 milliliter. What I would like you to do right now is to pause the video and talk to the people throughout the class and find out what were their slope values. After talking to your classmates, you may notice that many of the slope values were near 1 cubic centimeter for every milliliter. If you were to talk to all the chemistry students, you'll notice that that was true. There's a few students, however, there were outliers where they had values such as 0.2 cubic centimeters for every milliliter, or maybe 0.7 cubic centimeters for every milliliter. Usually that's attributed to incorrect or not as accurate measurements or calculations. What we end up finding out in this particular lab is 1 cubic centimeter is the same measurement as 1 milliliter. Please write down what is in this box. The last variable within this formula is the b. B represents the y-intercept. One of the questions in the lab, the very last one in the conclusion to be specific, asks you about, do you keep this value in your formula? So the question is to be or not to be. We use this thing called the 5% rule. So in the 5% rule, if the y-intercept is less than or equal to 5% of the maximum y value collected, the y-intercept is negligible. What that means is you take a look at your data and you look in your y-axis, that particular data, meaning the calculated volume. Look for the largest value. What is 5% of that value? The easy way is to move the decimal one place to the left and divide it in half. If you move it one place to the left, that's 10%. Dividing it in half makes it 5%. Compare that value to your y-intercept from your statistics on your graph. If that value is more than the y-intercept, you would get rid of the y-intercept value. If that y-intercept value is larger than your maximum y value, 5% of that y value, then you would keep it. And that is the end of the discussion. Feel free to rewind or rewatch if needed.